Hello, it's Programmer's Life. Good evening. Back from where we ended in the previous episode, we had introduced functions. We had talked about the different types of functions, and we said among the types we have what we call user-defined functions. Then we said we have what we call inbuilt functions. Then under user-defined, we talked about pure functions, and we even talked about function prototypes. So we went ahead and we showed how a function looks like. We even had an example of product. We talked about the return statement for a function that is carrying out an execution. Then we talked about a function that might never require a return statement. Now, still from there, let's try to have another example. Now, we had only given a single function showing an example of a pure defined function. So let's have another example for a more better understanding. As usual, syntax is C++. So here we have a definition of a function which raises an integer to the power of another positive integer. Okay, assume we have such a function. Without forgetting, we said all functions are written to perform specific tasks. So this time around, my function will be known as the power fun. Okay, I have int power fun. And it's gonna take two parameters. I can say int base, then unsigned int exponent. Okay, of course you can just find a simple function within the math library that will help you compute the power or the power of two numbers, having the base and having the exponent, what we call the weight. But what I'm trying to do right now is I'm trying to show you how better can you have more function examples for us to understand. So we're going to use a for loop. Shall say int I is assigned 0 and this is less than exponent, and we shall have a pre-increment. So in our code can have result. Hope we are fine that way. Definitely if it's carrying out a computation, then we shall say return result. So that is another example. Okay, that is another example of a pure function. It's declared and at the same time it is defined. That is why we said a definition of a function. So we declared and defined at the same time. So if you realize, one, as a reminder, this function has a name, it's called power fun. Then at the same time it has a return type, okay, and it has two parameters. So since it's carrying out a certain computation that is which is already recorded here, then we are commanding it to give us whatever it has done at the end of the day. Are we there? Now after understanding this, there are quite a number of concepts that come in. One, let's talk about variables once again. Now we know what a variable is, we know how a variable looks like, but variables have types. Why are we talking about types of variables? Because whenever we begin handling functions, it is very hard that you want to look into the different types of variables. So for that case, it means that there are those variables that are only accessible within the body of the function. I'm saying it again. There are those variables that are only accessible within the body of the function. And those variables are called local variables. These are called local variables, or they are sometimes called auto variables. Now, each time we declare a variable, either inside the body of a function, that is within that, or a class, within that, then those are called local variables. Okay, so their accessibility is only within the opening and the closing of that particular function. So from the previous example, we have a variable that is called result. Okay, we have a variable that is called base. We have a variable that is called exponent. So those variables are local to that function, meaning they are not accessible outside the method. So we are saying they are not accessible outside the method. So that is what we call a local declaration. That is what we call a local declaration. Now, in our explanation, we've said these variables are also called auto variables. Now, because the lifetime of a local variable is limited and it is determined automatically, these variables are also called automatic. I'm going to say it again. Because the lifetime of a local variable is limited, I told you how is it limited. It is within the opening and the closing of the curly braces. So since it's limited and it is determined automatically, that is why these variables are called automatic variables. Okay, so you can call them auto, or its complete form, they are called automatic variables. Now, another note, the storage class, they are called storage classes. The storage class specifier is auto. The storage class specifier is auto. So this is known as automatic, or what we call local variable declaration. So example, we can have at least one example. Assume I had a void function which is called tester. Okay, and it's having a single parameter which is void. So I can say auto then int my my var. I can say auto int my var. So definitely this is the same as int my var. Okay, with or without putting auto, it is definitely the same altogether. But one thing that you need to know is that this is rarely used. It is rare that you would find a programmer or someone declaring a local variable with a keyword auto. Reason is because by default local variables are automatic. I'm saying again, by default local variables are automatic. Now we have another type of variables which is called the global variables. Guys, we are still talking about functions, and we said since functions have what we call declarations, then in those declarations there are those data storage areas of variables that we deal with. So that is why we are giving it a deeper understanding to know the different types of variables that can be encountered when we are handling functions. And the first type that we identified was we have what we call a local or automatic variable, and we've talked about that already. Then we have global variables. Okay, now these are declared outside. It's actually the opposite. Outside any method body or class. These are defined outside any method body or class altogether, guys. For example, I told you programming becomes easier when we have examples. Assume I had a main function. And here I have some piece of code. Now outside this main function, if I had a variable like maybe int year, and the year is 2021, our current year, then maybe I have a function int max, and I'm checking the highest of the two values, or the biggest of the two values. So definitely this one is called a global declaration. I'm commenting just for proper understanding. And this is called a global function. This is called a global function. So our target was here. I should say global variable declaration. So year is outside this section. It's outside the opening and the closing. So its scope is global to the program. Okay, so if a function is global, I mean if a variable is global, like I've told you, it means it has been declared outside the body of any method or a class. Don't ask me what a class is, we are yet to be there in the coming or future episodes. So maybe one very important thing that someone needs to know here is that because you might ask, why do we have global variables? So global variables are accessible throughout the program. Okay, but yet we said where was it? They are not accessible outside the method. So this is accessible throughout the whole program. Within the method body, or should say or class and outside. That is what it means. So the best example that we've had is that int year or year as a variable, it is outside the main function, so definitely that makes it global. So hope that is really understandable. So we have other types of variables, but these are not really usable, or they are not really implemented. We have register variables. I'll just hint on them. Then we have what we call static variables. So there we are. Now there's another one which is so important, apart from the ones that I've talked about and not listed here. We have one which is called external variables. We have one which is called external variables. So external variables. Now external variables, I'm going to talk about them, but in form of an explanation. Hope you are really attentive for understanding. Because global variables may be defined in one file, okay, we have a possibility that there is a global variable and it is defined in a certain file. Then it is deferred to, or it is referred to, in another file. Now, in some means of telling the compiler that the variable is defined elsewhere may be needed. I'm saying it again. For purposes of global variables, there is a possibility that I have declared the variable in one file and I want to refer to the same file for that same variable. I'm in some other file, I want to refer to the other file, okay, so that I begin using the variable again. Now there has to be a way to tell the compiler, okay, that the variable that I'm using right now is defined elsewhere, if you really need to know if it is in existence. Now if you don't do that, automatically as usual the compiler will complain that the variable is undefined. So how do you do that? How do you sort out such a problem? This is facilitated by an extern declaration. We use a keyword extern, okay, so we use a keyword extern. So for example, use a keyword extern. For example, I can say extern int size. Now if I say extern int size, it informs the compiler that size is actually defined somewhere, maybe later in this file or in another file. So this is called a variable declaration, but not a definition. I think we're getting the idea. But right, I'm talking about it, but something that you need to know: it's a poor programming practice to include an initializer for an external variable. I know some things we really need to note. It is a poor programming habit. It is a poor programming habit, okay, to include an initializer for an external variable. Guys, I remember telling you we are doing programming, so that is why certain concepts may not be easier to grasp from there and then, but this is the way to go. So focus on understanding, but not cramming the way things have to flow. So I'm saying, I told you, there's something, however much I've talked about using the extern and how it comes about, telling the compiler that I'm not using this variable for the first time to avoid it from giving complaints. We are saying something very important that you need to note in this section. It is a poor programming habit to include an initializer for an external variable. Are we together? Why? Since this causes it to become a variable definition and have storage allocated to it, or have storage allocated for it. All together? So if I come and say, this is what I mean, and I told you examples work perfect, sorry about that. If I come and say extern int size, then I set 10. Wow, whoa, this is definitely no longer a declaration, so problems have already risen for that case. So if there is another definition for size elsewhere in the program, it will eventually clash this one. That is what I mean. Okay, so note that. It is really very, very important. So that is about what we call the external variables. So for that case, you can also use constants, you can use quite a number of aspects there when it comes to variables. Okay, in the next bit, let's try to look at what we call function calling. Let's try to look at function calling or function invocation. I want to remind you once again, somewhere when we had just started functions, yep, it is here, I told you a code fragment or snippet that is written to perform a specific task when called. I told you calling also means invocation, and I again talked about it under the operations on methods. I told you when we are to handle methods, we do what we call a declaration, then we do what we call a definition, then we do what we call an invocation. So all along we've been talking about how to declare and how to define. Now we are talking about the third operation, which is called invocation or method calling. Now method calling is the actual use of the function. Method calling or is the actual use of the function, or I told you the function can also be called a method. So it's the actual use of the function. Now each time we talk about method calling, something is really very important. So the actual use of a function or a method, or maybe we can say it's the execution of the method. That is when the method comes into play. That is when it really performs the task it was intended to do. All together? Now here, if a method is to be called, we use a certain syntax. Syntax is method name or function name, then we have what we call parameters. That is the syntax. Method name, then parameters. It means I'm calling that function. Okay, now if I'm calling the function, then what is going to happen? We need the method name, that one we already know. Then we need parameters. Now at this juncture, let me talk about parameters in details. Now parameters have two types. Parameters have two types. One, we have what we call formal parameters. Guys, let's try to understand functions so very well, because they are really key where we are going, and they are really key in the language. So we have what we call formal parameters, and we have what we call actual parameters. Don't forget, we are still under what we call function calling. Here it is, for someone who has not yet discovered why it is. So we are still talking about function calling, and we are saying this is the syntax. We have the name of the function that we are calling, then we specify the parameters. So I'm trying to explain that syntax. So parameters, I've told you we have two types of parameters. We have formal parameters are also called placeholders. Mark that, they're also called placeholders. Now formal parameters, these are parameters sometimes we can say values are defined in the function declaration. Okay, these are values or parameters that are defined in the function declaration. Now we can pick examples from here. Where I started from in this episode, I had a function called power fan, and I had the base and I had exponent. So this is an example, or these two are examples of formal parameters. Once again, from the previous episode that we had where we introduced functions from, again we had another function which was called product, and we had int x and int y. Those are also known as formal parameters. So the ones that are put into the declaration, actually we even went ahead somewhere where we said these are declared and defined at the same time. So I told you declaration, what is in the declaration? It is return type, identifier, and parameters. So these type of parameters, these parameters which are talked about in the declaration, they are ones that we call formal parameters. I think I'm very clear for that case. Now we have what we call actual parameters. These are stated at the calling of the method. In fact, actual parameters, sometimes they are known as arguments. Guys, I'm very sure I'm very clear. I'm trying to move slowly so that people can really understand what is really going on. Okay, so I'm saying actual parameters are also known as arguments. These are stated at the calling of the method. So I think we are connecting back to function calling. Note the number of formal parameters is the number of actual parameters. What does it mean? If the formal parameters were 2, then the actual should also be 2. If the formal parameter was 1, then the actual should also be 1. If the function never had any parameters, then even in the calling please don't give it any parameter. Are we together? Now I know for us to understand this very well, let's try to have a basic program. Now as usual, I think I should write here without wastage of time. Now my program has already started after there. So from what I've had, we had int power fun. Okay, we had int power fun, and around here I have a pure function. Okay, around there I have a pure function. What's about this function? It is declared and it is defined at the same time. Okay, so what is going to happen? We can have an opening statement as usual. So a program that computes the power of any number. I told you here you can have any statement of your choice as long as it makes sense. So here I will say cout enter the base value. Enter the base value. So it means I needed a local declaration. I'm combining concepts from what we have just talked about. So I'll say int b. Okay, so b is local to the main function. The same way result is local to power fun. Okay, then I can also have, actually let me have b and e. B to mean base and e to mean exponent. As usual, I always advise you to declare and initialize. So since we have asked for the base, let's capture, so someone will enter the value, then copy and paste is a design error, sorry about that. Enter the base value. So here the base value, instead of saying base value, first we shall call it enter the weight value. So this is gonna be e. Okay, now calling the function. Okay, calling the function. So in calling of the function, I'm going to say cout. Okay, I'm going to say cout. Then actually what I'm going to do, let me make it real. So I'm going to say b to the power e is, so a call to the function. We said when we are calling a function, we use a function name, then the parameters. So I'll just come here, copy and paste to make things perfect. So how many parameters does it expect to have? It expects 2, the base and the exponent. So I'll say b and I'll say e, and I'm very sure our program is working as expected. Are we together? So as usual, Ctrl A, Ctrl C, we are going to compile. So a program that computes the power of any number. So enter the base. Our base is gonna be 4. Then 44 to the power 2. server is a bit low. So 44 to the power 2 equals 244. What did we do? Okay, checking here again. Said result is result is assigned result times the value that you've given as the base. Okay, yeah, I think that is fine. So our target was not basically to have it computed, but based on how we stated it somewhere, a definition of a function which raises an integer to the power of another positive integer. Okay, so we are fine. Now still under calling of a function, where should calling be done? Where should calling be done? One, calling can be done in the main function. Calling can be done in the main function. In another function, calling can be done in the main function and can also be done in another function. So from the previous program that we had, where is it? So here we had a calling and it is inside the main function, but again we can have a method that calls another method. Okay, so pure function up here, let's try to have another. Let me say let's say void, sorry about that, let's say void my details. Let's say void my details, and I'll say int age, and I'll say string first name. Okay, I have another function, so what is this function going to do? This function is going to print, so it will be cout hey who, hey f name, again you are age years old. That is all that it's going to do, okay, as a function. Now again I can have another function. This other function is going to be I think to organize our program so well, let's put the function here, void void, let's call it greet user. Okay, so it's a void function, but for it it has no any parameter. Okay, so this is outside, so we're gonna put it there. So I'm having another function here. Okay, so yeah, okay, so greet user, shall say cout shall leave a space, and how are you doing these days? Okay, So I have a function greet user and I have a function my details. So I call another function from here. What am I going to say? I'm going to say greet user. So definitely I think someone has already noticed where it's going to take us. So at the invocation of my details, if someone entered 23 and said Simon, it's going to say, hey Simon, you are 23 years old and how are you doing these days? I think that is definitely a nice one. So in the calling I'm only going to call my details, and automatically my details will internally call greet user. I think someone has already noted that. So I'll have another variable here, and this variable is int my age, and it's initialized to 0. Then I'll have another one, string name. Okay, so after the invocation of this function, then I'm going to say cout how old are you? You the user, how old are you? So cin is my age. Okay, then cout as usual, what is your name? Okay, I've forgotten this. So what is your name? So still once again I'll say cin name. Okay, so here call call to the function. Which function was that? It was a void function and it was saying my details. So I'll say my details here. First it expects the parameter for age, then it expects the parameter for name. Wow. So once again, so our program is having about 3 functions. So what does that mean? It means that the program can have as many functions as possible, but our target was to show you the calling places, the possible calling places of any function. And one was the main function, then another one was calling a function from another function. So base value I'll set 3 and I'll set 2. So definitely that is 3. So how old are you? I'm 78. And what is your name? Of course there is a poor organization, but don't worry, you can correct that. What is your name? My name is Simon. So it says, hey Simon, you're 70 years old and how are you doing these days? So there is an invocation of 2 functions at the same time, just from the program that we had in this section. Okay, now right now I think before I continue, so for any questions please about functions, then it means you must have watched this episode and the previous episode to make things more clear. As of now, please don't forget to subscribe to my YouTube channel, Programmers Life, and thanks for watching. I sign out.